The discussion of time symmetry was started with the theory arrow of time, proposed by British astronomer Arthur Stanley Eddington in 1927. But till now it is one of the biggest unsolved questions in physics. According to Eddington, it could be determined by studying fourth-dimensional space-time structure of atoms, molecules and bodies. Since it is believed that almost entire microscopic level physical processes follow time symmetry, but it is not the case in macroscopic level. If you want to check whether the event is time symmetric or not, then simply play a video of an event and it would seem realistic whether you played forward or backward. Let's understand it through an example. Suppose I have tossed a ball up. It would slows, stops and then fall. If you record this event and play in both forward and backward, it looks equally realistic. Hence the system is time symmetric. However, the process of the ball bouncing and eventually coming to a stop is not a time reversible. So till now it is related to the real life examples. But now we look at it from the perspective of physics. According to second law of thermodynamics, entropy of an isolated system increases with time. For example, a car that has rusted could be said to have a greater entropy value than a new car. Basically, the molecules of the car have become more disordered over time as entropy has increased. Thus, all microscopic processes appear to be time reversible. It is very widely held misconception that change of entropy is in some way fundamentally time asymmetric. That entropy change behaves fundamentally different in the forward time direction to the backward time direction. This is absolutely not the case. In the general case, change of entropy behaves exactly the same way in the forward time direction to the backward time direction. But according to second law of thermodynamics, which states that entropy increases with time, this seems to imply a fundamental time asymmetry to entropy. But we have to realize that the second law only applies to special case systems, objects with low entropy, the sort of an object we generally encounter in everyday life like resting cars. In fact, if we consider general case objects in thermal equilibrium, which have never been arranged into any sort of order, then their entropy is at the maximum already, so their entropy can only decrease with time, completely at odds with the second law. This misconception that change of entropy is fundamentally time asymmetrical is called as L'Archimedic paradox. Another physicist, Roger Penrose, in his book The Road to Reality, suggested that by considering a graph of entropy of universe where it started from a low entropy, and it can be seen how it continues to increase to its present entropy at A, which further increases to point B in the future. However, Roger Penrose then suggests that if entropy change is time symmetrical, then we should expect the path of the entropy of the universe traced back in time from the present point A to follow the path to point C. But this is clearly not the case when we trace the path back in time. Till now we deal with the fact that entropy is asymmetric in universe. But what if it is symmetric as we believe? Then how universe was started? We have to imagine a universe which started in thermal equilibrium and has reached its current state unaided purely by chance. After that, the low entropy point is reached. We then start increasing the entropy according to the second law. But the important point is that if we detect the entropy of the universe in time before the low entropy point, we now see the symmetry that Roger Penrose sought. Therefore, the transformation of entropy is fundamentally symmetric. After all these discussions, we can understand that time is symmetric, but still few theories explain that it is asymmetric in nature, like the weak measurements in quantum mechanics, black holes whose symmetry must be a white hole, and even few topics in classical mechanics like velocity, linear and angular momentum of a particle, and many more who doesn't follow the time symmetry. So guys, that's all for today's video. Please like this video, and if you are curious to know unknown topics in physics, then subscribe my channel. And at last, thank you for watching.